Hey guys, okay, so let's go through this warm-up. First thing you should always check is, can your equation be factored? That's the first thing we can check. It looks like we can a little bit, just from looking at it. We can take out a GCF of a 2. And then we'll check, can this piece on the inside be factored? So let's see, y equals 2. I need two numbers that multiply to -8 and add to -2. So I think that'll be 4 and 2. And which one do I want to be negative? I think I want the 4 to be negative because then they'll add up to -2 and they multiply -8. Okay, so now that we have this in factored form, we can go through and find all the various pieces. First thing I like to do when I get it in factored form, I like to find the x-intercepts. So I'm going to go ahead and do that. So for the x-intercepts, that is when our graph will cross the x-axis. I'm not sure how it looks, but it's when it's going to cross the x-axis, and that occurs no matter what point it is on here. It'll occur when y is equal to 0, right? It has to be when y is equal to 0. So we will go ahead and plug 0 in for y. And then we can solve this thing for x. So I like to divide out this 2. I think that's really easy to do. 0 divided by 2 is still 0. Oops. And we get x minus 4 times by x plus 2. Then I have two things multiplied together. They equal 0, so I can use the zero product property. Either x minus 4 equals 0 or x plus 2 equals 0. Solve for both. X equals 4, x equals -2. So my x-intercepts are 4, 0 and -2, 0. So I'll plot those. Now, from here, this is where I like to find the vertex. So the vertex, what you'll notice is the vertex is going to have to fall somewhere right in between my two x-intercepts, right? This graph is going to be kind of something like this, and my vertex will have to fall right in the middle of it. So what I can do for the vertex is I can take the average of the two x-intercepts. So I'll do that. So the x-coordinate of the vertex will be 4 plus -2. Again, these are my two x-intercepts. And then divide that by 2, so that is 2 over 2, which is 1. So I know my x-coordinate for the vertex is going to be 1. What I don't know is I don't know where it's going to fall on the y, right? I know the x will be 1, but I don't know what the y is. So I can just double check. I'll go back to my original equation and just plug in 1 for x. So I'll get y equals 2 times by 1 minus 4 times by 1 plus 2. Go ahead and solve this. Y equals 2 times by 1 minus 4 is -3. 1 plus 2 is 3. So let's see, I get -18. Okay. So now I know my vertex is going to fall at 1 negative, oops, wrote that in the wrong spot. 1 comma -18. Now I'm going to go ahead and find the y-intercept. So the y-intercept is when it crosses this y-axis, right? And that'll always occur. What is my x-coordinate at every single one of these points, right? That'll always occur at x equals 0. That's the equation of this line right here. So what I can do is just plug in 0 for x, and I can solve for y. So I get y equals 2 times 0 minus 4 times 0 plus 2. Y equals 2 times negative 4 times 2. So this is negative 8 times 2, which is negative 16. So this point will be 0 comma negative 16. And the very, very last piece is this symmetrical point. And for the symmetrical point, like we know what the left side of the graph will look like. The issue is we need this point of symmetry to the y-axis. So what I really like to do is I like to draw this line of symmetry, right? And then it's really clear to see where this symmetrical point will be. So I know this is a distance of 1 to my y-axis. So if the point's symmetrical, I'll have to go a distance of 1 out here. And this will be my point of symmetry. Or symmetrical point to the y-axis, or the y-intercept, right? And so that point would be, what is that, 2 comma negative 16? Okay, and so this is your factored form.